Welcome back. So we're gonna try example number 5. We're gonna use the logarithm properties to compress this expression and solve for x in terms of a and b. So so here is an example of solving for x. We often what we try to do is isolate the logarithm that has the variable, which is already isolated, and then we try to compress it using some of the logarithm properties, which is already compressed, right? There's only one logarithm, so doesn't seem like we have to do much on this side. What we need to do is simplify the right side so that we can express this in terms of a and b. So let's begin. So what we're gonna do here is just use some algebra and try to simplify this as much as we can. So this is 1 times 1 logarithm, 1 times logarithm b, so that gives us logarithm a plus logarithm b. Here what we can do is use the power property and bring down that power. So that would be 2 times 8 times logarithm b. And then this 6 will be multiplied to every logarithm here because there's a parentheses. So by algebra, we use distribution. This will be 6 times logarithm b minus 6 times logarithm of a. And if you can see here, there's a lot of things that can be, be combined because these are like terms. We can combine them, right? So anything that is logarithm of a can be combined with any logarithm of a, right? So we see here that this right here and this right here both are logarithm of a. So they're like terms, or they're the same term. Yeah, terms that we can combine, right? So therefore, we can say that 1 logarithm of a minus 6 logarithms of a, well, that will give us minus 5 logarithms of a. And with the same argument, we can say, well, here we have 1 logarithm of b, and here we have 2 times 8 logarithms of b. 2 times 8 is 16, so maybe we can just write ourselves a note here. This is 16. And then we have plus 6 logarithms of b. So we can say 1 plus 16 plus 6 gives us positive 23 logarithms of b. So that will give us, then that's pretty much it, right? But then what we can do here is, well, now we can use this exponent and bring this power over here, right? We can use the power rule and we can bring this up. And we can bring this one also up. Right? Maybe I can fix that one like that. And then we can, now if you notice, we started with a few logarithms, and now we only have 2 types of logarithms. And because the logarithms have the same base, that means we can compress it to one single logarithm. Because this was addition, this turns into a multiplication within the logarithm. And at this point, we can say, well, they both have there's the same logarithm on both sides of the equation. And our goal is to solve for x. So can we isolate this x by removing this log? And the answer is yes. We can undo the log by applying the exponential form of this value, right? We can say, well, we can raise the left side to as an exponent of 10 and 10 to the right side. And so we can say, well, as long as we put the same thing here and here, then those two are still equal to the same thing. And it happened to be that this is equal to this. So we're going to say, well, we're going to raise that side to x and raise this side, right, a minus 5b to the 23rd. And well, because, and the reason why we chose base 10 is because we already know, as we explained in the intro, that this logarithm is technically base 10. So we're going to undo this one This is going to undo each other. This is going to give us x equals a to the negative 5 times b to the 23rd, right? And this, because this has a negative power, we can say, well, this is the same thing, but to be a to the 5th, right? And this gives us the solution, right?